This is Papa Bale, and welcome to the channel. There we go. All right. What are we looking at here? All right. So this is uh, there we go. So I'm going to rearrange those coils to this rotor. I mean, it is pretty close. We'll take a look at it, what it's like with the coils the way they are. That's so smooth. All right, here we go. Let me explain it real quick. All right, we got the circuit starts here at a 14 gauge coil with 19 turn or 900 or sorry 90 turns. 90 turns in this coil. 180 in this coil. It's 18 gauge or 1 millimeter. And then we got 20 gauge. Inside of that one is 725 turns. So we get, as we go, the gauges get higher, and the amount of turns get higher as well. All right, and then from 20, we go over here to 26. And there's 3,174 turns of 26 in here. Then 28, there's 1,111 turns of 28 in here. And then we go over to the middle of this coil, which has 3,333 turns of 32 gauge. So this is like a transformer coil. There's a coil inside a coil, and then a core inside of that. Wow, okay. Then we got a 32 gauge coil by itself, and that's got 3,333 turns. So this functions pretty good, but as you can see, the stator is about an inch out to a half an inch out in some places. Everything with the core is about an inch out. So we got 1,259 RPMs right now. We're going to move everything in, and see, we're generating 47 DC volts, which I'm then running through a 25 volt capacitor with 4,700 micro in it. and then reconnecting it to the positive of my power distribution. So it goes right back into the, right on top of it actually. Well, let's see. Actually, I haven't done this, but let's do this. We're going to take this off. We're going to give it another reading. Wow, 1261. I think that might have actually helped. I like that. Let me test this cap real quick. Something's draining it. I don't know what's going on with that. Oh, there we go. 12. About 12. 12 volts. It shouldn't be draining it. It should be Well, I'll worry about that cap later. But for right now, I'm gonna put it right there because it doesn't hurt it that much. One more reading and then I'm going to take it all apart and put it back together a different way. So it's the same, 1261. Try and get that picture a little better. There we go. All right, so let me get down to business here. Where should I start? Start at the beginning. All right. See, that's what I never did when I started, and it's bad for my personality to set parameters because my ruling sign is Jupiter, the big ass planet. You know, so my stuff's gonna be bigger regardless, man, just right off the bat. It's all gonna be bigger. Bigger than what? Bigger than it needs to be, you know? It's all going to be maybe big to the point where it's less efficient. You feel me? Like, that's how I do things. As close as we can. That's good. That is really good. Alright, so I think I'm gonna go to the other side now. Well, we got this one, but I gotta get the glue sticks. Now, there's probably something that I missed. If anybody's trying to leave a comment. Alright. So that's in there. Take this one. Oh. Man, this glue, this package, this very large package of glue, it's a lot stickier than the last package. See, I could actually work with the last package, and these are just ridiculous, man. You can't unlatch it. You need a heat conductor to melt it, and it feels to the touch like it wouldn't even melt that good. That is beautiful. These three right here might actually, let's see what happens. Because if I'm just screwing stuff up, man, I'm gonna stop. All right, ladies and gentlemen, what we're looking at here is the amp funnel. So the circuit starts here at 14, goes to 18, then to 20, then to 26, then to 28, and then to 32. This is a transformer coil. It has a coil inside a coil. There's a 32 gauge coil in there. That is awesome. $12.72. I was right about that. Look at that. Oh. $1,300. Wow, that's continuing to increase at a phenomenal rate of speed. You go see if I can't get a microphone real quick. Alright, so yeah, what we're looking at here, very cool. So that worked out in our favor tremendously. Those are air coils. We got a lot of speed out of that. What do I want to do next? 26 or 2032. So now the power is off. Got some flywheel action happening here. Yeah, what I don't want to do is break the ends off the 32 because they're already really small. They broke. And it's funny because they broke like right when I got done wrapping them. So it's like I got an end, but it's like a freaking small end. So if it breaks, you know, it's not good. And that whole part of that coil becomes virtually useless. Now, should I go around the other side? I think I should. Alright, so this is a big coil right here. This is a lot of power comes through here. Transformer power comes through here. You know, we wrap the looks like we wrapped the big one first to go along with the amp funnel. Because it's two experiments combined now. You got the transformer coil and you got the amp funnel. You really gotta choose one, because if you do it, you know, it goes, because if you put that 32 gauge coil in the wrong order, then it's not the amp funnel. Plain and simple. Alright, so we need to get this around here. That hopefully, oh man, nope. Till the blue. I might have to back it out just a little bit. Yeah. All right. Oh yeah, those are powerful magnets. What this is telling me is that the blue or the surface isn't magnet. Yeah, and just imagine if I left those 32 hooked up, man, it'd be wrecked right now. So that's about half the distance that it was. So. And those cores are kind of hard to negotiate sometimes, especially if your magnets are strong. behind me right now. I'm gonna see. Not much is happening back there, and that's all right. Just like making a video with live commentary. All right, so we'll do 26 next. At 32 gauge generation coil wires getting mixed up with the wires. And unmix it. Oh yeah. Oh yeah. Just gotta let that glue set a little bit, and then it should be all right. All right. So we're almost there. And having these extra coils in the offset position, so cool. Especially with the amp funnel, because they're all being used, even if they're not actually driving, because when those amps get cut, it forces it as speed or voltage. So what I did have before was the one inside was the last one, and now this one is the last one. I don't know what the difference is. All I know is that all the changes I've made have fluctuated the RPMs between 800 and 1300. And I made so many changes that I haven't really kept track of all of them. I just kind of keep track of the ones that work the best. Yeah, this glue is like quote unquote way better than the last batch of Gorilla Glue that I got. It's like way more unagreeable with me. It's like get it right the first time or pay the price. Maybe. I was wrong. But then I set it up. And that's alright. Looks like this one comes first and then that one comes second. That's exactly what's up. Hold on, let me make sure I got that right. Alright, so double check one more time. this way, and that way, and that. Alright, cool. We're almost there. Just need to move that generator coil in a little bit. Now that core will slow things down a bit, but that's okay. Now the cool thing about this core and the generator coil is that it's made out of iron filings. And I really want to get it in the offset position. And that looks pretty damn close. Alright, let me get some glue on it. Since this is the first live stream I've actually set up myself, I hope I'm doing alright. I know there's probably something I missed during the setup process, but I'll get the hang of it. Yeah, that's all iron filings, packed about 98%. So if there is like a part enough to make a hole, it'll be in the dead center of it. It'll suck it all out to the sides because either that or it'll push it all to the middle. But I think it's going to suck it all out to the sides and it'll be like a little donut. Sliver, tiny ass donut. Alright, let's do it. You might be in the wrong spot, but wow, dude. $780. Wow, we're doing 100 volts already. 107, 109. Wow, dude. That is super, man. That is freaking awesome. See, look what happens. That's awesome. I just moved everything in a little bit and just bam, it took off. Get a readout on this capacitor here. How can anybody use this? No, I'm gonna have to get thing. Up here. It's about half full, but what it's doing is it's spending. Doesn't look like it's really doing much right now. Okay, let me take this off. I'm just going to go up for a while. That is so cool. Look at that speed. That is phenomenal. Alright. I'm going to take it out of the holster here. Yo, what's up, man? Check it out. Heck yeah, that's amp funnel right there. And with that little rotor, we got 128 volts. I can't seem to charge a capacitor enough to use it though. Thanks, man. I appreciate it. Should have seen it a second ago. I had it all spread out. So when you're charging a cap to use it, and you want to use it simultaneously as you're charging it, you hook it up parallel, right? Am I right about that? So right now I have it hooked up in series, and it seems to be spending. I don't know why it's spending. The output is not hooked up. Parallel with, what I want to run it parallel with is the power distribution positive side. And the generator coil. So it would be powered by the generator coil, and then it would power or add power to the parallel or the positive power distribution. That's my objective. But with all my attempts, I haven't been able to charge the caps. Jewel Thief would be really awesome right now. Well, for DC, all right. And you mean the one with the counter on it, right? That one right there. Gotcha. The manual labor, but of course, you know that winder actually winds faster than my my stepper motor. Because you can crank that thing. You can get 22,000 turns in like an hour. reed switches are really good for using the transformers. These little bad boys. Yeah, and I just got done. Whoa, sorry about that. I didn't mean to flip on anybody right there. This bad boy right here. My next Celtic Cross one. That looks like a little tiny magnet, doesn't it? That's 3 inches long. It goes the entire length of that square part right there. So it's got like an inch and a half north and an inch and a half south. That is the most what am I getting at? You know, like my big magnets over there on that rotor, they have 10 millimeters of north and 10 millimeters of south. I mean, it's a big magnet, but that's how deep each one goes before it starts wrapping around. These ones right here, these 1 inchers, they're a little bit, they're 25 millimeters. So there's like 2.5 millimeters more power for these magnets. Yeah, heck yeah. It's a Celtic Cross though. That's what it's supposed to be. Like a little mini one. Yeah. Yeah, I'm finding out. And then these ones, for like that little tiny area right there, are the most powerful magnets I've found on the market. These are N52s and they got an inch and a half of north. The entire cylinder is magnetized. So I don't know, man. That's power right there. That's pretty powerful. I like this one the best though. Look at that baby go, man. Look at how close. Look how close that is. That is so awesome. What is that GAUSS, man? What does that mean? Is that what I'm talking about with the magnets? I'm not familiar with the word, so. Yeah, that little bad boy goes about as fast as this one does, but it doesn't generate nearly as much because, okay, yeah. Yeah, that's what it is. It, for that little tiny spot, for that 1/2 inch area, I haven't been able to find a magnet to hit that sweet spot harder than that one does. But this one has like is wider on the face, so you got a lot more room to work with. Huh. Yeah, I was running some of this DC electricity that I got from the transformer. It's about 100 volts right now through that coil, that pancake coil, and the little coil in the middle of it. I didn't get them to levitate, of course, but I did get a strong magnetic field that north and south, pointed to the center. And there's a strong magnetic flow to the center. Alright, so strength of the magnetic field. Yeah, and I'm telling you, I think it has something to do with the size of the magnet, where you have the north on one side and the south on the other, whichever hemisphere you decide to cut it on. Um, whether you cut it on both hemispheres, I don't know how complex magnets can become, but I do think that if they're if the magnetic pole is on, say, the tip of a cylinder, instead of like cutting it down the middle, long ways, you cut it down the middle small way, and like cut it in half like that instead of like this. You get so much more power out of it because you got that much wrapping back on itself. You know what I mean? So I don't know. I'm pretty sure it's kind of the same thing that we're talking about. Wow, my phone got down to 5%. I had to plug it in. So like 128 is the most electricity I've gotten out of this rotor so far. But see, this is the energy, the voltage that's inside the cap, and the cap is got no outlet right now. The cap is just wasting away. I don't know why. Oh, I get what you're saying. Can I hook it up standard, like just AC standard? Yeah, and that's how lights work. I think that should be just fine. Um, yeah, man. Especially with that new rotor that I made, because the opposite poles are like right next to the shaft. I mean, it's like right on the shaft, and so the shaft becomes very magnetic. I think I do. Let me double check that real quick. See how long this 15 feet USB will go. Yeah, that sounds like fun. Mm, looks like 26 and 28. Maybe 26 and 32. I got I don't know. Trying to find a single filing. Like small gauge. Here. Not that one. I might take it off the amp funnel right there just to get it going. Yeah. I know I got one around here somewhere. shelving system instead of this red. Alright, I have one. It's 26 gauge. It's 333.3 turns. Alright. Now you're saying just like up here, right? Just like down the shaft like this, right? Yeah, let's see. Let's see here. I'm gonna put the camera. If you can't hear me, that's okay. I'm sorry. But I am going to hook that up. I'm gonna put the camera back up here. Sorry, apologize. Alright. Let that catch up. Come on now. Alright, let's do it. And now 18 single file. I got this 14 single file, but I know that's not enough. You gonna work on the shaft too, or just that? Got a lot of iron content in the shaft. And I wish I had like alligator clips like this, but with like, you know, a wire like this big, you know? So this is the EMF that you're talking about, right? Let's try the other one. Because that's a steel core. This one over here is iron. Yeah. Wow, look at that. All right. You got it. That's that wireless transmission. Yeah, that's neat. I wonder what will happen if I put it on the generator cord. Let's see what. this one I love this one. Pretty sweet. Yes. Yeah. Now, I'm just curious. I don't know. I can't see it. It's probably not working. I was just checking because there's so much iron in that hole. Yeah, this one works. So you know what? I'm going to invest in the soft iron cores. Maybe, I don't know, is ferrite? Will ferrite core do the same thing? But that's a 12 volt LED, and that's like a really high-end LED. Not like a 100 watt, but it's like for a 5 volt setup, maybe it's a 12 volt LED. Okay. Yeah, I think I'm going to do the soft iron cores because they fit. You bother me. Sweet. That's not even blinking. That is like straight. Pull out the end. A little bit right there. So it actually has a range of about probably the middle of that tape ball right there. You mean like a flow bulb? Or an LED? I got this. That's a 15 watt LED. That's a black light. Try that. Alright. Well, oh no. It's alright. They didn't pop open, thank God. All my resistors is strong for it. I got up to 1,000,000 ohms. I was trying to hook up my system with a resistor. I got up to 1,000 ohms and every single thing fried. 10 to 1,000 burnt up instantaneously. So I'm up to like 10K now, and it doesn't work. So I don't even use them anymore. I'm like, yeah, 10K is too much, but 1,000 isn't enough. All right, so there it is. apart. Now I can catch this in a cap and it'll probably work just as good, right? Not quite enough. No, this light definitely will run on AC. Yeah, straight up, and hook it directly to that big coil and plug this up. I think it needs about 50 AC volts, but yeah, because this is the lamp for it, plugged right into the wall. I think we need a little bit more wire. Probably a little bit smaller gauge too. That would be awesome. But you can capture that, right? You can capture that in a capacitor, right? Okay. Yeah, I don't think this one is going to work because it's not even iron, it's steel. But that is the big one. This is 20 gauge right here. That's 32 gauge, and I'm pretty sure it's not going to be from this one. Yes, that's got power running through it. This one right here. All the cords, all the coils except this big one right here have power running through it. All right, let me see about that real quick. So there's only 180 turns in that green one. But let's see if I can do this bad boy. This is a foot long, man. Awesome. Wow. I don't know about this one. I might have to change them up real quick. And then maybe buy some new cores. I got aluminum cores, about the same size as that steel one. Bada bam. Oh, you mean just like this? And then just hold it close, like that? Don't want to get it too close. Wow, that's tight. Alright, let's turn it back on. It usually happens right away, right? Well, I should get more cores. I have a core for each one of these, but I change it up so often now. Wow, this is getting pretty hot. not sure about the light. But I could get it. Yeah, it is a cool trick. Thank you for teaching me that. I think I've seen it, and then I didn't understand what was going on. And then I saw it light up and everything. Coil there. Yeah, that's cool. That actually feels hot to touch. So you're telling me the beanie bifilar coil has a strong EMF, like a transformer EMF, right? I think it's called a CMF, but it's a transformer. Kind of the same thing. That's how transformer works. That very principle of the wireless transmission. Oh, yeah, that's nice. Nice. You're gonna make a larger rotor. I was so desperate that I actually splurged. Take me to pulse. Oh man. My mind is weak. Oh, yeah, I got these things, man. These little awesome things. I'm gonna put them to good use. So, do you think 32 gauge would work better than the 26 gauge? Gotcha. So, gotta have it big enough. And, I mean, is it like the smaller gauge, right? Does it matter how much wire there is? You have to be a smaller amount of wire? Like 50 turns instead of 5,000? Which one would work better? More the merrier? Alright. So, what I got as a suggestion for that is this bobbin right here. See, it gets right in the slot like that. Slide. If there isn't like a piece of tape. But I can like, so I'm kind of getting the feeling that you're not going to be able to charge a capacitor with it. Put back in that. You know, I've heard these magnificent stories of EMF, but I haven't really been able to utilize it at all until that little coil trick that you showed me. Everybody's like, use the back EMF to run your other pulse motor. I'm like, okay. You can explain that a little bit more in detail. And then I'm like, I really don't think any of these coils are going to have enough pulse motor. That's what it takes. But the energy that's coming off the back EMF, that's pulse, right? Because this whole thing is pulse. So that's pulse. It's created by the collapse of the magnetic field for a pulse. But I got it. Yeah, so it does pulse. And it's pulsing phenomenally fast because I didn't see it picking at all. Oh, yeah, man. I was getting into building my sculpture. This, I'm going to drill out the center. This should be a 1/2 inch. It's going to go around. Might have to make another rotor because it's going to go on this. It's going to go, it's going to step up each time it goes around. And then this one's going to start over here and it's going to step up. That's going to be dope. These things are going to have magnets on them, so they'll spin. They're all going to be spinning at the end. Yeah, it's supposed to represent human DNA. What I'm debating is whether I'm going to have the center go up with each successfully completed level. And I have 3-foot poles, so it's going to be 3 feet high. Now it was weird. I think I was using a transformer. So, but one of these poles, these bad boys right here, I'll bring you over in a second. And one of these 1mm coils since there's so much iron in this pole, you send that transformer energy through it, and it's going to just should hop up the pole. Doesn't matter whether it's DC or AC, because it creates a magnetic field, and that's an iron pole. But I tried running it simultaneously with the pulse motor. It sucks all the juice out of the system. Well, I mean, maybe a little bit smaller, but the coil that I used was virtually this size. I wish I had them. I saw it when I unloaded it the other night in the other room. I pulled out a bunch of these, and yeah, you're right. They were a little bit tighter. Yeah, so I can make it a little bit smaller. I see what you're saying. Yeah, and that might be right. I was trying to do it for my brain, my memory, trying to get the size right. But this is a little big, actually. I got this one setup that I was doing in, I recorded it all on Facebook, but I virtually had 6 poles and then 6 toroid magnets in a hex, and a pole in the center. One of these poles, of course. They're special. I mean, they're very magnetic. And so you had the hex, and you had this, they were centered. All of the toroid magnets were centered on these 1/4-inch poles. Like, this is marveling ingenuity right here. You just put it on this ring like this, and boom, you get it right dead center. You don't have to worry about it. And then I had these other discs. I think I put them away, though. I call them my levitation discs. And they're virtually just like 6-inch variety of this disc. This little one right here, or an 8-inch variety, or a 10-inch variety of. Like the 10-inch, we have 72 magnets on it. These little magnets. And it would go in the center pole, and it wouldn't be directly hovering over any of the magnets, but it would be floating there on the center pole. Oh, you did? Alright. Sweet, man. Thank you. That's awesome. Yeah, that was like one of my first aha moments of like, do we really even need electricity? yeah, dude. I watched the new ones, and then I watched the old ones from Kale. Yeah, Kale, right? Is that like what do we call it? General Kale from Willow. Or is that your real name? Yeah. Okay. Yeah, that's cool, man. That's a cool name. It reminded me of the evil general from like Kale. General Kale. Come on, you've seen Willow, right? How did I know what? Because I watched your old videos, man. Your old channels. You have your name. Not on a video, man. Your channel is the name of your channel. It's like, I forget what the first part of it was, but it's like, you know, Go Kale or... It's Kale, yeah. That's the one. It's Kale. That's the one I watched anyway. And I watched, so there's another channel, is what I'm saying. Sorry, man. I saw it. The original Peter Hall effect. So I'll check those out. Yeah, because I checked the link on one of your videos and it took me to It's Kale. Yeah, that 10-inch levitation disc that I built, spin with your hand, it was good for 15 minutes without a bearing. But you want to see it now? I got it right over here. I mean, I moved it around so many times that, and I ended up using it for maglev of the outer instead of in by the pole. The outer rim. So yeah, that's cool. I put these big brown ones on all the little ones and I glued them on. And it would lift the rotor up. But it would, since there's like spaces in between all the magnets, you could actually see that occur in rotation. So it's not good, or it's not as good as pole, but it works. But yeah, man, this is like utterly destroyed. It's like totally destroyed. There's only like 50 magnets left on each side. Yeah, look at this. This is beauty, man. This right here. Look at how well. Yeah, look at that side, man. That is like, that's the idea of what it's supposed to be. Then I got this 8-inch one where they're like interlocking pieces, and they can, like the 8-inch, then has like a 4-inch ring, and then the 6-inch rings will fit right on top of that 8-inch and that 4-inch, and it just stays there. You can stand on this freaking thing. That's a little over-exaggeration, but it is very strong. We got the 2, we got the 4 and the 8 pushing up the 6. That is good. this right here, man. I can't wait to get started on this because I got these magnets that fit big. But I don't know, man. This is the best way to do it because these are the flattest that you can make. The acrylics are straight as fuck, clear, got light shining up through the middle of these things. Look at that. Look at that resonance. It's my favorite color. Yeah, you can have any color shade you want. So what I do is I glue two of them together. And I get my drill press, my mini drill press, drill a 1/2 inch hole, and there's a 1/4 inch hole. I mean, I have 1/4 inch bearings, and I have 3mm holes, but I don't want to do that. I got these boosted bearings. Put one of them in here, hook it up on a pole. Let me show you one that I got done with the 1/4 inch. This one right here. But as you can see, the bearing was so small that I couldn't get it centered or glued in straight. That's about as straight as it's going to go. So I ended up opting to drill a bigger hole, use the bigger bearing, and use the bigger hole. Yeah, it is. And I was like, man, that's not going to work, dude. I mean, I've been dealing with this wobbly shit all just buying the printers didn't even fix the wobbly stuff. But I did get, cheap ones. Nothing major like Prusa or the Enders or anything like that. I just got some Cobras. I'm good with that. But I am kind of disappointed in the ability to not wobbly stuff. Like this one right here, is depending on this. It's not bad. I mean, it's not terrible, but it is not straight. And I have two awesome ceramic bearings in there. Wow, that was a perfect drop. That's a nice bearing though. Yeah, I got a piece of aluminum. I can get aluminum. Maybe. I think there's a place that could do that for me, like PCB Ray. Oh, did you manage to see that one video that I made where I had that lathe motor underneath, and then I had one of these poles sticking up with Okay. Oh, you mean like magnetic coupler? Kind of? Lens lock. Alright. Perfect. That's what I'm actually trying to do with this piece of aluminum that I got. All the coils and stuff. Yeah, that's what I was. Yes, dude, that would be awesome. I don't need any copper though, do I? Like on the rotor or anything? Got it. Right. Well, I don't know if I should do this. I'm not any good at doing this. Let me see if I got it right. And that's perfect, actually. Man, I wish there was something that I could put this in. Yeah. Do an offset hole? Yeah. That's what I'm trying to find is something to, so I can put it in there so it won't move around. And then I can, maybe if I like tape it. I think that'll work. Oh, I gotta turn that off, actually. Do that in a second. It looks like the glue is actually starting to melt. Especially on that 32 gauge coil. That's awesome. Alright, so got my trusty friend here. So, did the power company ever come knock on your door? It does? I heard you can't turn back the meter. Alright. That might just be a myth to dispel people from actually doing that. Nice. By how much? I think it's only because of the backlash, not like the actual physical backlash doing that kind of stuff. You were running? That's pretty fast, man, back from 2015. I mean, Jesus. I didn't even think they'd come out with gig internet until like 2020. Yeah, I know, but there's all kind of bottlenecks out there. Even like stuff you don't know about. And you just found a way to bypass that, I guess, right? Yeah, I know when the net came out, but I mean, when the net came out and when there wasn't even an Ethernet cable around when the net came out. I got you. Oh, I think I'm gonna get it. I think I'm gonna get this. Almost there. I like to take my time with these. I don't know if I got it yet. Really close. Alright. That's what the problem was. Alright, dude. Me too, dude. I'm getting there. With this dang thing, I don't have my chuck. Gotta take that battery acid to keep your head straight. Yeah, this is not working out the way I thought it would. Hell yeah. Alright, we're gonna see what we're working with. Put that off to the side. Come on, man, stop spinning. Here we go. So it looks like we made it through the first one. That's neat. Heck yeah, man. From the heart. This sculpture is gonna be the shit, man. It's gonna be the bomb. It looks like I only cut through one of them. There are two of them glued together, so. Let's see if we can work at it from the other side. Let's not do that. Maybe. Alright. Well, actually, there's a nice little groove. Yeah, that would be sweet. So we got this little hole here. We need to cut out a little bit more of that. Man, this thing doesn't like to stay together. Alright. I need a flat surface. Yeah, man, I'm getting tired. Thanks all. Hope it was entertaining. Heck yeah. Alright. Heck yeah. That'll be fresh, man. And then I could like you know, like the pulse motor could actually be used for something other than lighting up a light bulb. You can actually make art with it, man. That's gonna be awesome. Because seriously, that is the only good that I found with the energy so far, is lighting up a light bulb. Straight up. That's about all I've been able to do with it. Heck yeah. See, now what I wanted to do was I wanted to make a perpetual motion machine. It was half pistons and half magnets. Just permanent magnets. No electromagnetism, just permanent magnets and pistons. And that's it. Those pistons can be run on steam, or those pistons can be run on magnetism, but not electromagnetism. That's what I've been trying to do. That's what I had almost like a dream about, but when I was awake, having like a skeleton. I think I've heard the last name, but not the first name. What's he famous for? good. Thought that would be cleaner. Anyway, just gotta move it around a bit and it'll come loose. Oh, you mean like Robert Bearing? It's virtually trains, correct? See, this is where I think the flanged bearings right. I've seen Tesla's water turbine. Or should I say viscous liquid turbine. That's the only thing that he couldn't get to function because it would always keep on melting on his ass. And he was using oh dude. Yeah, man. I mean, I think he only got it up to like 20,000 RPMs, but it was made, the discs were made out of such flimsy material that they would melt. And they needed to be flimsy. See, that flange bearing fits right in the hole. Right in the hole. Perfect. We have to get some more of those. Wow. Damn. Well, I'm gonna have to wipe this down. And then I'm gonna have to get some glue and another bearing. See, steam, I think, is all about pressure, isn't it? So what you would do is you would heat up an inductor, which would be the coils, and that inductor would heat up the water, and the steam would perpetuate the motion. That's brilliant. All you need is a bunch of water, and you're good. So this is good. This one is good. Thought I could do it, and I did it, and it worked. Yay. All Yeah, man, I think I'm gonna call it. Gotta start. Yeah, you could power it on rainwater. Yeah, I could power on any water. You just need, you need that water, and you need to be able to take that water with you. Say if you're going towards Albuquerque, New Mexico, not a lot of rain down there. Yeah, man, toilets are a engineering marvel. Albuquerque? Yeah, that's where my son's or my brother's daughter lives with their family. Oh, look what I found. Just for looking. I found one. Well, it's not a flange though. Yeah, I'll ask my brother if he knows about that place. No, that one doesn't fit. Huh. You know what I think? There it is right there. Oh. Hmm. No, I haven't seen Sky Collection. But we both watch my buddy 3D printed pulse motors. You know the guy I'm talking about, right? He works with PCB Wave. Wow. I can only see the one. I'll have to check them out. This is going to be the most challenging aspect of the whole night. So we got a super glue. The bearing without super gluing the bearing. So that bearing still works. Awesome. So the only problem with doing it this way is that now I need flanges that are this size. So this, over here like so. That is so perfect. Oh man, I love it when I get it right. Yeah, I did that too. Or I would have done that. But I got it right. Yay! I didn't screw it up. All right. So I need my trusty chest. It's always got one of those little Allen wrenches in it. So I keep putting it back in there. Hey, thanks, brother. Alright. See, totally adjustable. Boom. Boom. Now let's see how that double one spins. Awesome. So I heard it called pendulum something. Having all these things spin at the same time is called pendulum something. Alright, let's some paper towel. Clear off because it's got that white Lucas oil lithium grease on it. Bam. Alright, I'm going to give it another spin and then I'm going to shut her down. Man, that voltage goes up so fast, we're already at 100 volts. Alright, that's awesome. I love how it just keeps on picking up speed. That's best. Alright, thank you all very much. Peace out. Have a great night. Please subscribe. Bye now.